Assalamu alaikum. Today we're going to be talking about aldehydes and ketones. Yes, indeed. Aldehydes and ketones are a very interesting part of organic chemistry because they're very, very similar. They in fact share the exact same functional group, a carbonyl thing, which is C double bond O. However, they are slightly different in one sense and one sense only. Aldehydes have a carbonyl group attached with a hydrogen, whereas ketones have a carbonyl group attached to two other hydrocarbons or any other compound there. That's the only difference between aldehydes and ketones. But this very simple difference makes them have very different reactions, which we'll see when we start studying about reactions. As for the naming, they're pretty simple. Aldehydes end with al. Alcohols end with ol, ol. Aldehydes end with al. It's quite similar, but it is a difference nonetheless. For over here, I have an aldehyde with two carbons. So 2 carbons is S, so this is ethanal. Let me write that down. Ethanal. As for the ketone, we've got 2 ways to name it. The olden ways to name it was we saw the 2 alkyl groups. So in this case, these are 2 methyls. So this would actually be called dimethyl ketone. However, we don't use that anymore. Instead, we actually use the ending of ketone, which is -one, as our suffix. So this is 1, 2, 3. This is 3, so that's prop. So this is propanone. Let me write that down. Propanone. And we have to mention which carbon the carbonyl group is at, and that's at carbon number 2. Either way you go, it'll be at carbon number 2. So this is 2-propanone. That's it for naming. It's actually that simple. As for the properties, the small molecules of both aldehydes and ketones are water soluble, and they cannot form hydrogen bonds because there is no hydrogen attached to the oxygen. However, they can accept hydrogen bonds because they have an oxygen that has free pairs of electrons. For the reactions, which we're going to be studying in more detail and comparing them to, is oxidation, reduction, and acetal formation. So let's get started. Now we're going to talk about oxidation and reduction, and then we'll move on to acetal formation. As you can see, I've already written down oxidation and reduction, and I've added 2 charts of aldehydes and ketones to help compare the differences between what's happening. So aldehydes, when they undergo oxidation, what happens is they become a carboxylic acid. An oxygen enters into this position, and you get a carboxylic acid. I'll just write acid here. As for ketones, they do not undergo oxidation because they don't have a free hydrogen at the end of them. This is actually a very important test we use to differentiate between aldehydes and ketones. And 2 of the tests that you might need to know are Tollens tests, which produce a silver mirror when an aldehyde is added to it, and for Benedict's agent, which produces a brick red precipitate. Both of those tests will give a negative results if you add a ketone to it, but if you add an aldehyde, these are the results you will get. This is one of the most important differences we have to help us differentiate between what an aldehyde is and what a ketone is. As for reduction, they both undergo reduction. However, they end up with different results. You add a hydrogen here, and you add a hydrogen here. How do you get 2 bonds? By breaking this 1 bond. And the same thing here. You break this 1 bond, you add a hydrogen here, and you add a hydrogen here. So what are the results? Over here, what happens is you get a primary alcohol. Whereas for ketones, what happens is you get a secondary alcohol because you still have 2 groups attached to it on either side. So you get a secondary alcohol. That's it for oxidation and reduction. We're going to move on to acetal formation now. Now, hemiacetal and acetal formation. This is a new word, hemiacetal, but don't worry, you'll see what it is right now. It is a part of acetal formation, and as many of you already know, hemi means half. So you first reach hemi-acetal, which is half an acetal, and then you can move on to an acetyl. So let's move on. Let's start that right now. So an aldehyde is here, a ketone is here. We're going to see how they react with an alcohol. So if an aldehyde and a ketone react with an alcohol, that's when you start to form hemiacetals and acetals. That's a very important point to remember. So what happens here is this hydrogen connects with this oxygen, and this oxygen connects with this carbon. So you end up getting something like this. Something like that. Now, the hydrogen attaches here, and the oxygen, along with the rest of the molecule, connects right here. As for here, the same thing happens. This hydrogen connects with this oxygen, and this oxygen connects with this carbon. So you end up getting something. So this is what a hemi-acetal of a ketone looks like. Sometimes we like to call this a hemi-ketyl, and the full version ketyl, but that's the old speech. Nowadays we just call all of them hemi-acetals and acetals. So sometimes if you study from a book, you might see the term ketyl or hemi-ketyl. That's the same as basically saying a ketone reacting with an alcohol. The only difference to note here is they react in exactly the same way. However, there's a hydrogen here of the aldehyde, and there's no hydrogen here. Instead, it's going to be whatever constituent group there is of that respective ketone. As for acetal formation, we add another alcohol to it again. It can either be the exact same alcohol, or it can be a completely different alcohol. Hence I wrote R2. This is R1, this is R2. It doesn't really matter what it is, as long as it's another alcohol. What happens here is now a little bit different. This is a reversible reaction. Oh, sorry, I wrote plus here. This is a reversible reaction. However, this going from hemiacetal with another alcohol to an acetal, this is an actual reaction because you get some certain products. Here, this OH and this H join together to produce water. Likewise here, this and this join together to produce water. This O has a free bond now, and so does this O. This R2 has a free bond now, and so does this R2. So these two join, and these two join. And this is what that end result looks like. So if I draw out my hemiacetal out first, and then I add there. So you can see there's an acetal here and acetal here. They look almost exactly the same. However, like I told you, the only difference is the hydrogen here. As for hydrolysis, you can actually reverse this entire process by using a strong acid and lots of water. Thank you for watching. I hope you guys enjoyed. Make sure you subscribe to our YouTube channel, Meditorial, for more interesting and informative videos on medicine.